Hey class, we're going to talk about functions, which comes from section 1.1, part 2. Our objective is to use functions to model and solve real-life problems. So for us on our first problem, this is example 7, and it's describing the path of a baseball. So it says a baseball is hit at a point 3 feet above ground at a velocity of 100 feet per second and an angle of 45 degrees. The path of the baseball is given by the function below, where x and y are measured in feet. Will the baseball clear a 10-foot fence located 300 feet from home plate? Okay, so we could do this one of two ways, but what we're going to do is we're going to do this the algebraic way. And let's kind of break down what's going on here. I see that it says that we have a baseball that's hit 3 feet above ground. So that's where that plus 3 comes from, because that's kind of like your y-intercept if you want to think about it like that. The velocity of 100 feet per second at an angle 45 degrees. Well, that's kind of all within that equation. The fact that this is a negative function kind of lets me know that the path of my ball is kind of going downward, which is about pretty accurate. So essentially what we're hoping is that there is a fence 10 feet away that the ball will clear, that it will be able to go over the fence. And it says, oh, excuse me, that was wrong. This is 10 feet. This is 10 feet. And the fence is 300 feet away. So what we need to then figure out is which one describes x. Well, x, if we think about like a coordinate, like xy coordinate, x is usually your horizontal distance and y is your vertical distance. So that lets you then know what number we're going to substitute in for x. If x, again, is your horizontal distance, which is here, that means that we're going to substitute in 300 feet for x into our function. All right, so let's go ahead and try that. So we would have f of 300 equals negative 0.0032 times 300 squared plus 300 plus 3. I kind of gave up on trying to rewrite it in a different color. I guess I could have kept it. Either way, if you substitute that information into your calculator, remember this, either you could type it all in at once, or if you're going to do it piece by piece, just remember this section here, you need to do the power part first, so 300 squared, and then multiply that times negative 0.0032. Either way, the answer that you get is 15. So what that means is at 300 feet, let me redraw this, at 300 feet out, the height of the ball is 15. But remember, the fence was only 10. So this ball will clear the fence with about 5 feet extra of height. So yes, the ball will clear the fence. Just as a reminder, if it's a word problem, it deserves a word answer. So we should verbalize what the answer is or articulate it. On our next example, in example 8, we're talking about direct mail advertising. I know our textbook is kind of old, so direct mail basically is kind of like how you get, your sales flyers and stuff in the mail. But anyways, just wanted to throw that out there. So anyways, it says the money C in billions of dollars spent for direct mail advertising in the U.S. increased in a linear pattern from 1990 to 1992. Told you the book is old. All right. Then in 1993, the money spent took a jump, and until 1996 increased in a different linear pattern. These two patterns can be approximated by the function below, where t equals 0 represents 1990. Use this function to approximate the amount spent for direct mail advertising between 1990 and 1996. Sorry for that awkward pause. I'm reading between two different papers and I realize they're written differently. Either way, so we need to approximate how much is spent between 1990 and 1996. Remember, they tell you that zero, if I use t as zero, zero represents 1990. All right, we've already dealt a little bit with piecewise functions, but we're going to continue to deal with these piecewise functions. If we want to know everything from 1990 to 1996, then that means that we need to know not only 1990s information, but 1991, 1992, 1993, 1994, 1995, and 1996. And essentially, each of those then represents t equals 0, t equals 1, t equals 2, t equals 3, t equals 4, t equals 5, and t equals 6. Sorry, my little dashes are not going all the way through. Okay, so if that's the case, all we have to do is where these t values are, we have to be sure that where we substituted into our piecewise function fits the constraint of the function. So our first upper half of our piecewise function limits us to using those values that fall between 0 and 2. So that means the upper half of our information, or the upper function, will only use the values 0, 1, and 2 to evaluate. And then we'll use 3, 4, 5, and 6 with the lower function. So as an example, and I'll show you one example from each side. If I wanted to find c of 0, that would be 2340 plus 1.01 times 0. Well, obviously anything times 0 is going to go away. So we are left with 2340. So our answer over here, c of 0, is 2340. Okay. If I wanted to do the same thing for the lower half, let me do 3. So c of 3, that's a 3, my goodness. Why is a 3 not one to write? Oh my goodness. Okay, there we go. C of 3, that'd be 1985 plus 2.50 times 3. Okay, if we multiplied and then added, we would get 2735. So over here, we would say C of 3 equals 2735. All right, so I've already done all the work for these rather than showing you the work for each and every single one. So C of 1 is 2441. C of 2 is 2542. C of 4 is 2985. C of 5 is 3235. And C of 6 is 3485. So in total, if we are supposed to approximate our values, and I'm just going to kind of erase most of that. If we are supposed to approximate the values, then in the end, all we're really supposed to do is just add up all of those green values out to the side. And again, that's already been done. So if I add that up, the total, and again, these numbers are represented in billions of dollars, then that means that our total is 197.63 billion, or 197.63 billion dollars. I should say dollars. All right, let's keep going. Okay, let's talk about the difference quotient. And this is something that you'll use more so in calculus. I'm just kind of giving you an introduction to it, and we're literally just going to introduce it and jump right off. So it says one of the basic functions in calculus employs the ratio f of x plus h minus f of x over h, where h cannot equal 0 or does not equal 0. This ratio is called a difference quotient. So up to this point, we have practiced substitution. When you see the difference quotient, that's all I want you to think of is substitution. That's all you are doing. It can somewhat seem confusing, but please do not. We are going to look at it piece by piece. All right, so for f of x equals negative 2x plus 4, find the difference quotient. Okay, first of all, I'm going to put this function in a golden box because this is always our function. But anytime we see f of something, it's letting us know that we are creating a new function. So in two separate boxes, I am going to create a function here, and I'm going to create a function here. All right, so let's start with our first function. That would be f of, in other words, what it's telling me is that every place in this golden box function, so our original function, every place that I see an x, I'm now going to replace with an x plus h. So for us, that means as I begin to write my function, I have negative 2 times x plus h and then plus 4. I have completed that function with its new input. That's it. Then it has to be minus, and when I say minus, I also like to kind of put this second half in brackets just in case it's a lot going on. Now minus, then in blue, I'm just gonna, it says f of x, so that's exactly what that function says. So I'm just gonna match it. So I'm gonna rewrite this as negative 2x plus 4. And then in this case, it says it's all being divided by h. So again, what was in gold just got replaced, just the x part got replaced with x plus h. The second part, or that second function, just asked you to rewrite the function as is. Sometimes what is in the parentheses will not always be x plus h. It might be x squared. It might be j minus 2. It doesn't matter. All you have to understand is that it's saying write the function with this particular input for your value. Okay? So anyways, let's go ahead and continue to simplify. So if I simplify, first I need to distribute that negative 2. That's going to give me negative 2x minus 2h plus 4. I still have the plus 4 left over. And then I'm going to distribute this negative to everything inside. That's why I wanted to put it in brackets. So if I distribute the negative inside, a negative 2x becomes positive 2x. A negative positive 4 becomes negative 4. And it's all being divided by h. Now we start focusing on our like terms. What I see is that there is a negative 2x and a positive 2x. Then I also see there's a positive 4 and a negative 4. When I'm done, I get negative 2h over h. If I divide my h's out, I get negative 2. And again, it's negative 2 as long as h does not equal 0. If h ever equaled 0, then it would be undefined, so that wouldn't be our solution. But we will take this portion here as our answer. Students typically have a hard time wrapping their head around this concept, so we're going to do a try to practice again. All right, so on try 9, it says for f of x equals x squared minus 4x plus 7, find the difference quotient. So again, we're going to substitute. This is our original function. This is telling us to change the input of our function. And this one is telling us to keep our input of our function. Okay, so let's rewrite. Again, every time I see an x, I am changing it to the x plus h. So here we go. We will have x plus h and then squared minus 4 times x plus h and then plus 7. all I've done so far is rewritten my first function with a new input. Next, it tells me to subtract my original function. So again, I'm going to use brackets so that I know later on that I'm going to have to distribute that negative somehow. Okay, so if I keep my function, that's going to be x squared minus 4x plus 7. Everything stayed the same. Oops. And it's all being divided by h. And honestly, really it's just this first function that's a little funky. I'm going to do the work for this out to the side. So really this is x plus h times x plus h. Using distributive property, technically you'll have x squared plus xh plus another xh plus h squared. Usually I like to say alphabetical order, but I feel like xh is kind of the norm when we use it in math. So you'll have x squared plus 2xh plus h squared. If you ever write hx, it doesn't matter, just as long as you can find the other one to match with it. So for example, if you see a xh and then if this one had been written hx, just know that they were actually the same thing. So anyways, we're going to replace that first part of our function with x squared plus 2xh plus h squared. So here we go. This is going to be x squared plus 2xh plus h squared. Now we're going to continue by distributing. So negative 4 times x is negative 4x. Negative 4 times h is negative 4h. And then we still have the plus 7. Now we need to distribute this negative to everything. So negative times x squared is negative x squared. Negative times negative 4x is positive 4x. Negative times positive 7 is negative 7. And it's all being divided by h. What's nice is, for the most part, a lot of things get canceled out or simplified out, however you want to call it. So for example, I see a positive x squared and a negative x squared. I see a positive 4x and a negative 4x. I see a positive 7 and a negative 7. What we are left with then, and I'm going to put it kind of in order for us, meaning highest power to lowest power. I see h squared plus 2xh minus 4h divided by h left over. If I then divide everything by h, I am left with h plus 2x minus 4. And again, as long as h does not equal 0. And honestly, this polynomial h plus 2x minus 4, again, it didn't have to be in that order. I just chose to write it in that way. Guys, we are done. If you have any questions, please come see me for help and get some tutoring from me. Alrighty.